Today's lesson is based on Mathematics 2611, Linear Algebra. We are going to look at linear dependent and linear independent. Today's lesson we are just going to focus on two vectors. Let us start. We say two vectors are linear dependent if we can express one vector as the multiple of the other vector. Now remember, in this lesson video we are going to focus only on two vectors, so it's very simple. So suppose we have vector 1, which is v1, and then we have v2, then the question says, are these vectors linear dependent? Now what we need to do, we need to check if we can express one vector as the multiple of the other vector. Looking at v2, we can see that we can factor out 2 as our multiple or a scalar, and then we are going to have 1, 0, -1. Now we can see that this is basically v1. So we can conclude that v2 is equals to 2v1. Now since we can express v2 in terms of 2v1, this simply means that the two vectors are linear dependent. Remember, there are many ways to actually check whether vectors are linear dependent or linear independent. But for two vectors, it's simple like that. Let us look at more practice questions. Feel free to pause the video and check whether these two vectors are linear dependent or linear independent. And remember that vectors can come in many forms. In this case, you have matrices. Now let us check. We can see that vector 2 or x2, it has bigger entries compared to x1. So let us check if we cannot factorize something from x2. So x2 is equals to, when we factorize 5, we are going to have 1 here, then we're going to have 3, we are going to have 4, we're going to have 2. So we can see that this is actually x1. Then from here we can say x2 is equals to 5x1. Since we can express this x2 in terms of x1, then we conclude again to say this is linear dependent. This is our next example. We check whether these vectors are linear dependent or linear independent. We look at vector w2. We check if you cannot factorize a scalar multiple. We have 1, we have 3, we have 1. Since this is not equals to this, then we can conclude to say w2 is not equals to a scalar multiple of w1, or we can say again it's not equals to the scalar multiple. We cannot express w1 in terms of w2. Therefore, the two vectors are linear independent. When we are dealing with two vectors, it's simple. Our next example, we can actually see that we cannot express this entries with this one. So we can conclude by saying cannot express v2 in terms of v1, this is not equals to this. So v2 cannot be expressed in terms of a scalar multiple of v1, and v1 cannot be expressed in terms of scalar multiple of v2. So these are linear independent. Let us look at our last example. We have y is equals to 2, 4, 3, 1. We can see that this is not equals to this, so we confirm, actually we conclude y cannot be expressed in terms of scalar multiple of x. Then x is also cannot be expressed in terms of scalar multiple of y. Therefore, the two vectors are linear independent. There is the next lesson video where we look at how to determine whether vectors are linear dependent or linear independent, dealing with more than two vectors. That's it for this lesson video. This is Bohula SJ. Thank you very much.